Hello everyone, myself Basaraj Chogla. Today I will be explaining about the synchronization networks and synchronization in the PSTN or the telecommunication switching systems. Synchronization has the two subparts, frame alignment and the synchronization network. What is the frame alignment? For correct operation of time division switching network, the PCM frames on all the incoming highways must be exactly aligned. However, since incoming PCM junctions come from different places, their signals are subjected to different delays. To solve this problem, the line terminating unit of a PCM junctions store the incoming digits in a frame alignment buffer, as shown in figure 1. In the frame alignment, buffer will be filled by the incoming frames by phase difference between the frequency of incoming digital signal and the frequency of the exchange clock, and it will match the misalignment. Synchronization network. In a synchronous digital network, just one or two atomic reference clocks control the frequencies of clocks of all exchanges in the network. Synchronizing links may be unilateral or bilateral. In the first case, there is a master-slave relationship. The clock frequency of exchange influences the frequency of the other. For this purpose, synchronizing network is added to the PSTN in order to link the exchange clocks to the national reference standard. The local clock in each exchange is provided by a crystal oscillator whose frequency can be adjusted by control voltage. This control voltage is derived from the incoming digit stream on a synchronizing link, which is used to determine whether the exchange clock rate should be increased, decreased, or left unchanged. This ensures that exchanges maintain the same long-term average frequency, although short-term variation may occur. This is known as asynchronous working. Clock frequency of exchange influences the frequency of the other. In second case, there is a mutual relationship. Each exchange influences the frequency of the other. The principle of these methods are shown in figure 2. In this figure, single-ended unilateral, single-ended bilateral, double-ended unilateral and double-ended bilateral synchronizing methods are shown. Now in a single-ended unilateral, phase comparator is at the exchange B, and in single-ended bilateral, phase comparator is on the both the sides. If double-ended unilateral, if you take, there is a subtractor and phase comparator as well as a synchronizing signal from the channel from the one end to the other side. Now double-ended bilateral, synchronizing signal channel will be on the both the sides. In single-ended bilateral synchronous link, as shown in figure B, as above, decision process is made at each end of the link. As a result, both exchange clocks achieve the same average frequency. In a mesh of such a synchronous nodes, the exchange would mutually agree on a common frequency without being controlled by an overall master clock. A disadvantage of single-ended unilateral and bilateral synchronous system is that phase comparator are unable to distinguish between the phase changes due to frequency drift and those due to changes in propagation time. This disadvantage of single-ended unilateral and bilateral synchronous system is overcome by double-ended system, as shown in figure C and D. Synchronizing links may be unilateral or bilateral. In the first case, there is a master-slave relationship. This eliminates the influence of propagation delay variations by subtracting the change in phase determined at the end of the link from that determined at the other end. A signaling channel is required to carry the result of phase comparison to the other end of the link in order to make subtraction. For a unilateral network, as shown in figure C, this channel is needed in only one direction. For a bilateral link, a signaling channel is needed in each direction, as shown in figure D. Now next is a synchronizing network for integrated digital network is shown in figure 3. Since this is auxiliary network must link all exchanges in the IDN, the synchronous network has same nodes and the same hierarchical structure as the parent public switch telephone network. PSTN is a national network, telecommunication switching network. It is at level 1, level 2 and level 3 and level 4. It looks like a tree network and it has at the center reference exchange and then unilateral links and standby links, minor local exchanges at level and the trunk exchange levels it will be available. The synchronous links are provided by PCM system that carry normal traffic between the exchanges. So this will complete the module 4. Thank you.